Good evening, ma'am.
Good evening, sir. You can start, sir.
Good evening, sir.
Good evening, Ajay.
Good evening, sir.
Yeah, good evening. Madam, make me host, ma'am.
Sir, you can start.
Yeah, ma'am. So there's a lot of crackers. People are bursting crackers. Anyways, we'll continue. Last class, do you remember we did the derivations? Do you remember? Did you try practicing the derivations? Any chance? Do you remember at least we did the derivations?
Yes, sir.
Yes. Now we have done four derivations. I think four derivations we did. One is the rate constant of a zero order reaction. For a zero order reaction, rate constant K is equal to R naught, initial concentration, minus R, concentration after certain amount of time, divided by T. This is the rate constant for a zero order reaction. And we learned what is half-life period. Half-life period was defined as time required for 50% reaction to take place is called as half-life period. Half-life period we represented as T half. How is half-life period related to rate constant of a zero order reaction? We derived and we came to the conclusion T half is equal to R naught by 2K, or we understand that for a zero order reaction, T half is directly proportional to initial concentration. We learned it. And we also learned the derivation for rate constant of first order reaction. This looks very simple, but I derived it in a lengthier way, and in all steps I used and derived. And we understood that K is equal to 2.303 by T log of R naught by R, initial concentration by concentration after certain time T. And I wrote this equation K is equal to 2.303 by T log of A by A minus X. Ma'am, please make me the host. I lost connection, ma'am.
Yeah, sir, you can continue.
No, please make me the host, ma'am. I lost the connection, ma'am. My internet is
I made you the host.
yeah. My internet is making unstable now. I don't know why. All right, ma'am. All right. So for the first order reaction, we learned the derivation K is equal to 2.303 by T log of R naught by R. And we wrote this equation as K is equal to 2.303 by T log of A by A minus X. A is called as initial concentration. A is called as initial concentration, and A minus X is concentration after time T. After a certain amount of time T, the amount of reactant left is A minus X. This is A minus. This is corresponding to R naught, and this is corresponding to R. That is what we learned. And also we derived the relationship between half-life period and first order reaction, rate constant of a first order reaction. The derivation is there, and we derived it in detailed way. T half is equal to 0.693 by K. T half is equal to 0.693 by K. These four derivations we did. All these derivations we learned in solution state. When I say solution state, in aqueous medium. That's why we talk about concentration. When a reaction is performed in gaseous state, can we talk about concentration? When a reaction is performed in gaseous state, can we talk about concentration? Ajay? Can you hear me?
Sir, yes, sir.
Students,
No,
can you
sir.
hear?
Sir,
Yeah.
sir, yes, sir.
No, we cannot. We are
No, sir, we
performing a
cannot,
reaction
sir.
in gaseous state. Yeah. We have to talk about pressure. We have to talk about what? Pressure. Now we will derive rate constant of a first order reaction in gaseous phase. So in gaseous phase, we cannot consider concentration. We have to consider the pressure. Now, in order to derive this, we can consider a reaction like this. Consider a reaction A giving you B and C. A is a gas, B is a gas, and C is also a gas. For an example, if you take PCl5, this PCl5 on heating, it will decompose to give PCl3 and Cl2. All are in gaseous state. So this is the representation. Reactant A decomposes to give product B and C. Both are in gaseous state. Now we will mark, let the initial pressure be Pi. Pi is the initial pressure of the reactant. And we'll mark, let X be the decrease in pressure. X be the decrease in pressure of the reactant. After time t. Let X be the decrease in pressure after time t. Now, I will ask you a question and then we will come to the conclusion for this derivation. So far you understood, we have considered the reaction A giving you B and C. A is a gas, B is a gas, C is also a gas. The initial pressure of the reactant, we take it as what? Pi. P stands for pressure, I stands for initial pressure. And X is the decrease in pressure after certain amount of time t. Now we will try to understand this derivation. Now I will write the reactant. What is the reactant? A is the reactant. We have product B and C. Now I will write initial pressure. What is the initial pressure of the reactant? What is the initial pressure of the reactant?
Sir, Pi, sir.
Pi. What is the initial pressure? Ma'am, please make the host again, ma'am. Some problem with the net today. Hello, ma'am.
Yes, sir.
Hello, ma'am.
Yes,
Please
sir.
make with please. I don't know if there's something wrong with the net today. One moment. Can you see the screen, Ajay?
Yes, sir.
Can you see the screen?
Yes, sir.
Hello? Yeah. Yeah. Now we are deriving the rate constant of a first order reaction in gaseous phase. So we are considering the reaction A giving you B and C. A is the reactant, B and C are the products. Now the pressure, initial pressure of the reactant, we have marked it as Pi, and XB, the decrease in pressure of the reactant after certain time T. Now we know that A is a reactant, B and C are the products. Now initial pressure of the reactant is Pi. Initial pressure of the products B and C are 0 because no reaction is taking place. No products are formed. Therefore, the initial pressure of the products are considered to be 0. Now we can say, now we can write a decrease in pressure. Decrease in pressure. Decrease in pressure of the reactant and increase in pressure. Decrease, or maybe I'll write increase. Just a moment, there's no space here. So I will write it like this: decrease or increase in pressure. Now decrease in pressure of the reactant, as per the statement, what is that decrease? Let X be the decrease in pressure. That means X is decreasing. Now reactant from Pi, it decreases by the factor of X. It means, what is that? The product formed will be what? Equal to X. If I have 1 lakh rupees, if I give you 1 rupee, how much you will have? You will have 1 rupee. And how much I will have? I will have 1 lakh rupees minus 1. So initial pressure is Pi. From this pressure, X amount of pressure is reacting. So when X amount of pressure is reacting, it means X amount of products are what? Formed. So I took an equation here, PCl5. 1 molecule of PCl5 will decompose to here. 1 molecule of PCl3 and Cl2. Likewise, here in terms of gases, we take it as what? X pressure. Now, number of what's the pressure at equilibrium? Pressure at equilibrium. Pressure at equilibrium will be, this is Pi minus X. And this will be X and this will be X. This is, did you understand this so far?
Yes,
Did
sir.
you follow? Yes.
Yes, sir.
Yes. Now, what is the total pressure? What is the total pressure? The total pressure will be sum of these pressure. So this total pressure is represented as PT. That will be equal to sum of the pressure of A plus pressure of B and pressure of C. So it is Pi minus X plus X and plus X. So this will get cancelled. So total pressure will be equal to Pi minus X. Pi minus X. Or
Sir,
what will be
Pi
X?
plus X, right, sir?
Yeah, yes, yes.
So Pi plus X, right, sir?
Pi plus X, sorry, Pi plus X. Yeah, this plus X. So what will be X? What will be X? X will be equal to Pt minus what? Pi. So if you take this Pi to the left, it becomes what? Pt minus Px. Pi. So can I say we know that K is equal to 2.303 by T log of R naught by R, or I can write, we also know that K is equal to 2.303 by T log of A by A minus X. We know this equation. Since we know this equation, and I know the value for X, X is Pt minus Pi. So what I can write, K is equal to 2.303 by T log of A is initial concentration. Initial concentration we have represented as Pi divided by initial concentration is Pi. And what is X? We found out X here. It is Pt minus Pi. So on simplification, what we will get? K is equal to 2.303 by T log to the base 10 of Pi. What will I get? I'll open up the brackets. Minus Pt plus Pi I will get. So Pi plus Pi I get as 2 Pi minus what? Pt. Did you understand this? Did you follow?
Yes, sir.
So K is equal to 2.303 by T log of Pi divided by 2 Pi minus Pt. This is the formula to calculate the rate constant of a first order reaction in gaseous state. In gaseous state. Just go through this derivation. Just go through this derivation. Few more concepts you have to learn. So in gaseous state, what we have done, we have considered a reaction A giving you B plus C. And all are in gaseous state. So let the initial pressure be Pi of the reactant, and let X be the decrease in pressure of the reactant after some time T. So from Pi, how much is getting decreased? X is decreasing. It means X is reacting to give products. That's the understanding. We know that A, B, and C, A reactant, B and C are the products. So initial pressure of A is Pi. When time T is equal to 0, when no reaction has taken place, there's no products. Therefore, the pressure of the products are 0 and 0. After some time T, what is the decrease in pressure? Decrease in pressure of the reactant is X. Now, when the decrease in pressure of the reactant is X, it means the pressure of the products formed is also X. So how much of reactant is decreasing? That much of product is formed. How much of pressure is decreasing in the reactant? That much of pressure will be increased in the product form. So here, X is decreasing. That means product formed is what? X and X. So what will be the equilibrium pressure? Equilibrium pressure is initial pressure minus X in case of the reactant. And here there is nothing to minus, so it will be X and X. So total pressure is represented as PT. PT will be equal to the sum of the equilibrium pressure, Pi minus X plus X and plus X. You get PT that is equal to Pi minus plus X, or X is equal to PT minus Pi. PT is pressure after certain amount of time T. Pi is initial pressure, remember. So we know that K is equal to 2.303 by T log R naught. Or we can write the first order reaction rate constant equation as K is equal to 2.303 log A by A minus X. A is initial concentration, so we change it to initial pressure because it is in terms of pressure. So I write it as Pi. A is initial pressure, Pi minus this X we found out from here. X is equal to PT minus Pi. On substitution, we get K is equal to 2.303 log to the base 10 of Pi divided by 2 Pi minus PT. This is the equation. All right. Any clarification?
No, sir.
No. So now we'll have to learn certain graphical representations of first order reaction, all that. So I will erase this. Jaswant, did you follow?
Yes, sir.
Jaswant,
Yes, sir. Following, sir.
it's not there in the class. All right, we will continue. Just give me a moment in time. So in 12th in school, derivations are asked. Ajay,
Sir,
derivations are asked.
in this chapter, sir, I have only two derivations, sir.
What are those?
Sir, the one for sir, it's the previous one, sir.
First order reaction. Okay.
2.303 by
Okay.
yes, sir. First order reaction, and then half-life, sir, and then that's it, sir.
Half-life.
And then we have that one formula, sir, for that using log in terms of logs, sir.
Okay. And there is energy of activation, all that.
Yes,
maybe.
sir. Yes, sir.
That we will
And
do
then
it.
yes, sir. Arrhenius equation, sir. That's it.
Arrhenius equation we will learn. We will learn
Yes,
Arrhenius equation. We will learn all that. All right. Now graphical representations we have to learn. What's that graphical representation for a first order reaction? Now, for a first order reaction, we know that for a first order reaction, we know that K is equal to 2.303 by T log to the base 10 of R naught by R. This is the rate constant of a first order reaction. Now we are trying to talk about something called as graphical representation, where we can write R naught is initial concentration, R naught is initial concentration, and R is concentration after certain time t, after certain time t. Now this R naught also can be represented as A. Remember, R also can be represented as A minus X. We learned this. So we can write K by 2.303 or KT. You can cross multiply K into T. You can cross multiply T here, KT, and bring 2.303 to the denominator. KT by 2.303 will be equal to log to the base 10 of R naught by R. Is it okay? Is it possible? Cross multiply T with K and bring this 2.303 to the denominator. So what we get? We get KT is equal to log of R naught by R. Yes or no?
Yes, sir.
Yes. Now, if you take, how do I write log A by B? How can I write log A by B? I can write log A by B as log A minus what? Log B.
The log B, sir.
Yeah, log A minus log B. That is log R naught minus log R. So what will be log R? Now this log R will be minus K T by 2.303 plus of log R naught. So if you take this to the left side, you get a minus sign. You get a minus sign. Now, should I do that step? Okay, I'll do that step. KT by 2.303 is there here. Now you take this R naught to the left side log. So you get minus log of R naught. That will be equal to minus log R. Minus log R. So you shift this log or divided by minus sign. When you divide it by minus sign, what do I get? Minus KT by 2.303. Minus by minus becomes plus log R. Naught will be equal to log R. Same thing I've written here. Did you follow this now?
Yes, sir.
This is in the form of an equation y is equal to mx plus c. This is for what line? This is for what line? It's an equation for a straight line. This is in the
Straight
form,
line, sir.
yeah, y is equal to mx plus c. So when you plot a graph, log r versus time, we get a straight line. We get a straight line with a slope like this, and the slope is equal to minus k by 2.303. So this is the graphical representation of the first order reaction. So they can ask you to interpret the first order reaction rate constant equation graphically. So you should remember the negative slope. The slope is minus k by 2.303. Slope of the straight line is minus k 2.303. Here you can see this is nothing but what? The slope. Graphically, we can find this value by the slope obtained by plotting log r versus what? Time as a function. Yes? Understood this?
Yes, sir. Yes, sir.
Now we will work out some of the problems based on this. A lot of problems we didn't. We will try to work some problems based on this. Let's see. Now order, molecularity, all we've done long back. So based on that, we will work few problems and other problems for 12th also I will teach you at the end of the chapter. The first one is the rate of a reaction. The rate of a reaction A plus B plus C giving you product is given as R is equal to minus change in concentration of the reactant with respect to time. That is equal to, they've given K into A to the power half B to the power half, and C to the power 1 by 4. I told you order of a reaction is determined experimentally. Order of a reaction is determined experimentally. Order is defined as sum of the powers of the concentration terms in an experimentally determined rate equation. This is a rate equation which is determined experimentally. So what is the order of the reaction they're asking? The overall order of the reaction we learned it as, if for a general equation, a general equation rate is directly proportional to a to the power x and b to the power y. If we write, the order n is given as what? X plus y. The sum of the powers here. So the overall order of this reaction is equal to 1 by 2 plus 1 by 2 plus 1 by 4. So the LCM will be what? 4. So you will get 2 plus 2 plus 1 divided by 4. So that will be nothing but 5 by 4. The overall order of the reaction is 5 by 4. Did you understand?
Yes, sir.
Yes. Now the next one is the rate constant in case of first order reaction is. The rate constant in case of first order reaction is inversely proportional to concentration units, independent of concentration units, directly proportional to the concentration units, and inversely proportional to the square of concentration of the units. See, rate constant of a first order reaction, the unit for rate constant of a first order reaction is per time or per second in specific. So when I say the unit for the rate constant of a reaction, first order reaction is per time, it means it is independent of the concentration terms. It has no concentration terms. So therefore, the answer for this question is option B. It is independent of concentration terms. The next question. The rate law for a reaction A plus B giving you C plus D is given by the expression K into concentration of A. The rate of reaction will be doubled on doubling the concentration of B, halved on reducing the concentration of A to half, decrease on decreasing the temperature of the reaction, unaffected by any change in concentration of the reaction. Now, if you see here, the rate law R is equal to K into A. That is what they've given. The rate of a reaction is equal to K into A. That means we are not talking about B here. The rate is not dependent on the concentration of B. And they're asking, is given by the expression K into A, the rate of a reaction will be. So can I say the rate of a reaction is directly proportional to A now? Can we write R is directly proportional to concentration of A? Give a proportionality constant. It means it is directly proportional. Yes?
Yes, sir.
So rate is directly proportional. Now tell me what will be the answer. Read the options and tell me the answer. If you understood this, you tell me the answer. Take a chance. Let's see. Read the option. Doubling on doubling the concentration of B. In the rate equation, there is nothing called as B. Therefore, we cannot give this. Halved on reducing the concentration of A to half. So if you reduce the concentration by 50%, the rate of the reaction also decreases by 50% because it is what? Directly proportional. Therefore, the answer for this question will be what? Option?
So option B, sir.
B. Option B. Yes. Option B. A lot of disturbance today. The dog outside. Crackers. When initial concentration of the reactant is doubled in a reaction, its half-life period is not affected. The order of the reaction is zero order, first order, second order, more than zero but less than first. More than zero, less than first. It's a direct question. You can tell me what is the answer. It's a direct question we have learned, but I'll explain. You can also think for a zero order reaction, T half is directly proportional to initial concentration of the reactants. That is R naught. If you remember, we did this. Where is that? See, T half is equal to R naught by 2K. Or I wrote T half directly proportional to R naught. This is for zero order reaction. All right. Now you should remember all the formulas to work out the problems. It's directly proportional to R naught. Or we can write T half is directly proportional to the initial concentration. But for a first order reaction, we know that K is equal to 2.303 by T log to the base 10 of R naught by R. Initial concentration by concentration after some time T. We know that at time T is equal to T half, R becomes equal to R naught by 2, initial concentration by 2. So substituting in this above equation, what we get? We get K is equal to 2.303 by T half into log of R naught by R naught by 2. So on simplification, what we will get? 2.303 by T half log 2. This 2 goes to the numerator, R naught will get cancelled. So log 2 value is how much? Log 2 value is how much? 0.3010. That is equal to 0.693 by T half. K is equal to 0.693 by T half. We have derived the rate constant for a first order reaction. See here, T half is equal to 0.693 by K, or we wrote it as K is equal to 0.693 by T half. In this equation, is there any concentration terms?
No, sir.
No, that means half-life period of a first order reaction is independent of what? Concentration. Half-life period of a first order reaction is independent of initial concentration. What's the question? When initial concentration of the reactant is doubled, the half-life is not affected. Therefore, the order of the reaction will be what?
So first order, sir.
First order, because first order reaction half-life period is independent of the initial concentration. The next question. Are you following?
Yes, sir.
Yeah. Now the first rate of first order reaction is, see this, rate of first order reaction is 0.04 mole per liter per second. They've given you the rate at 10 seconds and 0.03 mole per liter after 20 seconds. 20 seconds after initiation of the reaction. The half-life period of the reaction is. They're asking you to find half-life period of the reaction. What will be the half-life period of the reaction? Clearly, they say it is a first-order reaction. For a first-order reaction, we know that K is equal to 0.303 by T log of, we can write initial constant R naught by R. Now, what is the rate constant? See, for a particular reaction, whether you measure the rate constant at 10 seconds, 20 seconds, or any time, the rate constant remains same. For a first order reaction, rate constant will remain same. So our work is to find out the rate constant of a first order reaction. So they have given 2.30. What's the time they have given? Final time, change in time is 20 and initial time is 10. 20 minus 10, it will be what? 10 seconds log of initial concentration, what they say. At 10 seconds, the initial concentration is 0.04 and after some time t, the initial concentration will be 0.003. So simplification, we can write 2.303 by t log of 4 by 3. On simplification, we will get 0.087 per second. This is the rate constant. Now, what is half-life period? They're asking half-life period for the first order reaction. Half-life period will be 0.693 by K. So it will be 0.693 by 0.0287. On simplification, we'll get 24.94 seconds. Ajay, can you hear me? Can Can you able to
Sir.
concentrate?
Sir, no, sir, we can't hear you, sir.
Crackers, can you hear?
Yes, sir.
Madam? Madam? Ma'am,
Yes, sir.
what shall we do, ma'am?
I don't know, sir. We can't hear you properly, sir.
It's the crackers, no, ma'am.
Yes, sir. Yes, sir. We can understand, sir.
What to do, ma'am? Today is Diwali in Bangalore, no? People celebrate Diwali today.
Yes, sir. Yes, sir.
If you permit me, I will wind up, ma'am, because nobody can hear.
Sorry, sir.
Ma'am?
Say that again. Say that
No,
again,
if
sir.
you permit me, I will wind up because no point, because nobody can hear me talking.
Okay, sir. Okay, sir. You can wind
We'll
up,
wind
sir.
up, ma'am. Yeah, ma'am. Yeah. We'll
Okay, sir.
continue with
Thank
the
you,
same
sir.
topic. Tomorrow we'll continue, ma'am.
Okay, sir. Okay, sir. Thank you, sir.
Bye, bye, bye.
Bye, sir.
Bye.
Thank you, sir.
Yeah, bye, man. Bye, bye.
Thank
Bye.
you, sir.
Bye, Ajay.